Where are you going to?
I decided I'm going to go to Wazoo.
Okay. What program?
Statistics.
Okay.
Makes sense.
Jordan? Okay. All right, you guys, today we're going to do, I'm going to wrap up this complex class example and then start talking almost the whole period about the fraction class, which will be due not long after you get back. And in the middle, we'll pause and let Jordan do his thing, and then you'll be free for 2 weeks. All right, any questions before I get going? Okay. Let's see. 17 out of 30. A little more than 50%, yes. And yes. All right. One of the things that we've briefly talked about, and I know that from where you're sitting, it's hard to see the rationale for the private-public section. I explained kind of the rationale, but I don't think anybody really believes stuff like that until they actually sort of viscerally work with the ideas. That said, if you look at the complex class here, we decided really just out of tradition to make the real and imaginary parts, the variables that hold the real and imaginary parts, we decided to make them private. And that's pretty standard. It's very rare for you to make a public variable in a class. But other than the fact that they're sitting in there, there's really nothing wrong. Like, there's no way that someone using your class could really mess up the class by reaching in there and changing the real part or reaching in there and changing the imaginary part. There aren't any real conditions on these numbers. They're just real numbers, a pair of real numbers that when you put them together, you get a complex number. One of the things that the fraction exercise is going to emphasize is that a lot of times there are conditions on the data that's in a class. And this is why it's protected from sort of general access. And let's go look at the fraction header and talk about this a little bit more. So, unlike the complex number class where there were just a pair of doubles, this section has 4 bits of information in the private section. And there are some comments there that are really important and that you really need to pay attention to. First of all, intentionally, I am making this class a little more difficult than it possibly could be, because I am requiring you to separate out the sign information, the positive negativeness of the fraction, and the numerator and the denominator. The reason for that is to make the class a little more capable. I'm going to use unsigned ints to represent the numerator and the denominator, and a Boolean to represent the sign of the fraction, whether it's positive or negative. If the sign Boolean is true, the fraction is negative. What's the advantage of doing this instead of just making numerator and denominator ints and letting the sign take care of itself? Can anybody think of a reason why I would choose to do it this way? Go ahead, Carter.
Numerator and denominator are both negative.
Definitely looks weird. So there might be a bit of an aesthetic there, right? Numerator, denominator positive, positive, numerator negative, denominator negative, still positive. Kind of aesthetically unpleasing. I have actually a more applied argument for why I would do this.
There are other ways to deal with it, but you can pull the bigger number this way.
I can have much larger numerators and much larger denominators if I make them unsigned instead of signed. The maximum unsigned integer is around 4 billion. The maximum signed integer is around 2 billion. Who really cares? So most of the fractions that you'd be dealing with in this class are going to be just regular old numbers between, say, 0 and 1,000 or something like that. So this is not really a huge issue. The point that I'm trying to drive home here is when you make choices like this, they have real consequences. When you make a simple choice like this, it makes other things difficult. And that's something that you'll have to deal with. So the numerator and the denominator are always non-negative and always in lowest terms. I'll talk about that in a second, the sign there. And then there's this function that's in the private section. This is weird. Normally, up to this point, the examples that we've done have had just data in the private section. But in fact, it's okay to put a function in the private section. And what this means is this function would never be used by someone that's using your class. They would never say f.reduce. This function can only be used inside the functions in the public section. So remember that the functions in the public section have free access to the private section of the class. So one of the things now, by providing a private reduce function, these guys can, like for example, the constructor with 3 arguments, the numerator, the denominator, and the sign, that guy will have access to the reduce function. All right, so the first comment, always non-negative, always in lowest terms. Whenever you build a fraction, you multiply 2 fractions, divide 2 fractions, add 2 fractions, subtract 2 fractions, the result needs to be in lowest terms. That's a condition on the objects of this class. If I'm using one of these objects, I, the programmer, I, the writer of this class, guarantee you, the user of my class, that it's always in lowest terms. That's a design choice. It doesn't have to be that way. That's what I'm requiring of you. So every object, every fraction object that I encounter is going to be in lowest terms. How do I put something in lowest terms? The reduce function is what will do that. And it's not up to the user of the class to call the reduce function over and over again. It's up to the writer, me, you, the writer of the class, to call the reduce function at appropriate times. As a brief aside, I considered having you guys write the reduce function, and then I decided, nah. So let me briefly show you some additions to the homework here. So I've added a link to the top of homework 6 to my version of the reduce function. And if you click through, you actually get the source just ready to drop into your class for the reduce function. This uses an ancient algorithm due to Euclid to first find the greatest common divisor of the numerator and the denominator. And then when you're all done, when you have the greatest common divisor, you just divide the numerator by that number and the denominator by that number, and it's in lowest terms. So you are free to go follow this link, highlight this, and copy it into your fraction.cpp file. All right, let's go back then and continue this discussion. All right. We have a few functions down here, in fact, a number of functions down here that return fractions. For example, let's look at this guy, the negation function. When I do f.neg, f.negate, how do you think that's going to work? First of all, what does negation do? What does it mean to negate a number? Haven't heard that one before? Or just change the sign, right? Either positive to negative or negative to positive. So it's the same as multiplying by -1. So negation, so how do you think you're going to accomplish this in the function? Say again? Well, I don't have a multiplication operator yet. Or maybe I do. I think it's easier though. Carter?
Just change the sign from true to false or false to true.
Right, so I have this sign variable, this Boolean. If it's true, I'll make it false. If it's false, I'll make it true. There's one exception. 0. For 0, what does it have to be? I actually said up at the top there. It says false otherwise, including when 0. That's actually a condition on the class. So it's not quite enough to just go in and switch the sign Boolean to its opposite. What's an extra thing that I'll have to do? Check the numerator. If the numerator is 0, then I'll set sign to false. Otherwise, I'll set sign to not sign. That's the kind of thing that you have to pay attention to. You have to keep, what's the word? You have to maintain the conditions of the private data, the private section. And now you begin to see why I don't want to let the user of my class have access to this guy. Because that person might reach into a fraction that is 0 and change the sign. And that's not allowed. Because there may be other things that rely on the fact that the sign of 0 is false. And so if I let the user reach in there and change that guy, it could break the class. It could break the conditions that I've set out for the class. And as the user of the class, I may be relying on the fact that the sign of 0 is false. Okay, let me pause there, let Jordan do his thing, and then I'm going to walk through the steps of getting started with this assignment. So come on up, Jordan. Do you need the computer? Yes, please. All right.
Okay, so I did my presentation on the OLPC project, which is 1 laptop per child. And what it's aimed at is getting a laptop to every child in the poorest countries. And it was founded by 2 U.S. nonprofit organizations. And what they were going for is, you can see the laptops. They're going for a design that no adult would want to use, so that there are no other markets for this this design. And so it was intended for children, and they wanted it to be. It can't be fragile or dangerous or heavy or big or any of those things. And so I'll show you kind of the hardware of it. So that's what it looks like. And they're coming out with, that was the first XO, and they're coming out with, now it's at XO 4, and it can be switched into a tablet as well. Here's the XO 3, so that shows you that. And so what they mainly wanted to use them for is just strictly education and connecting with people that have them, have this exact laptop around them. Their biggest kind of clients are South America. Has, Peru, for example, has 830,000 of these. And then Uruguay is the only country in the world that has, elementary school kids are required to have these, and they're given to them by the country of Uruguay. It's funded by they have a funding for the OLPC. And so I'll show you some of the software. They're very basic things, such as calculator. They have just art and stuff like that, and then there's reading for the kids, and then they can journal and everything. And let's see if I can find the neighborhood. Nope. So they can also, right here, you can see this is like this is what they call the neighborhood of like these laptops that are around them. And so in the middle that's the app that those children are using, and so the child with this laptop can see what their friends are using, and so they can join in with them, or they can like you can see the different apps that they can use. I can show you. There are 500,000 of these laptops outside of South America, but yeah, Peru definitely has the most, 860,000, and then Colombia and Uruguay are the next two, and yeah, I mean, that's pretty much it. They're used for educating the poorest children.
How much does one cost?
Oh, sorry, $230 is what they started at, and they're trying to drive down that price, but people are upset because they quote them at $230, and that's for if you order them under 100,000 units, and if you order above 100,000 units, then they'll cut the price in half. But a guy in Colombia, I believe it was like looking at the actual price, and he said it was like $430 with maintenance and other hardware that was necessary for the computer to run to its optimum conditions.
So in terms of hardware, it's got like wireless and
Yeah, it can connect. It actually has a further like network than any or like a regular laptop. So they were comparing like $1,000 regular laptop to this $200 laptop, and it can connect to any other OLPC or XO is what they're called, to any other XO. But that's pretty much it. Yeah.
And so the idea being that because they're this special type of computer, or they look like a child's computer, that it keeps it in the hands of the kid.
Yeah, exactly. And it uses a lot less power than any other like laptop, and so they can use them for longer periods. But they still have the same like displays. Like they said they compared it to just like reading a newspaper in like daylight. So yeah.
Are there any critics of this idea that you saw?
Not really. They wanted the price to be lower, obviously, and they're trying to drive down the price. They want it to be $75 by 2014, but there don't seem to be any critics of it. No, like they just want the kids to have a way to connect with each other and learn in a better way.
putting solar on these things?
Yes.
Okay, so you can charge it.
Yeah.
Okay. And then the networking is kind of cool because unlike you and I, where I bring my laptop in here and it connects to this wireless access point. You know, if you're in some village in Uruguay, there is no wireless access point, so the networks are all ad hoc. If you get two of these things close enough to each other, they form a network, and that's pretty limited, right? You can't go surf the web with that, but at least you can chat with this other person who's 4 houses down, or it doesn't even have to be 4 houses down. Like if there's a chain of these things in the village, right? Like I have one, my neighbor has one, and the next person down has them. They'll sort of all ad hoc to each other, and then I can send a message to one that's maybe out of range of mine through these other ones. Does that make sense? So it's pretty cool that way that you can build like this ad hoc village network, a wireless network.
Yeah. What I also found really interesting is that these also have programming on them for the kids, and they have terminal. So they have, you can see they have the Fibonacci sequence, Pascal, and like different Python programs, and then they can also just use terminal, just like you or I.
Yep.
Yep.
Cool. Any other questions? Thanks, Jordan.
All right. So let's talk about getting started with this fraction program. You'll remember, let's see here. fact, maybe I'll do this in the example directory. Maybe I won't. I want to make you go through this, so I'm going to do it somewhere else. So I'm going to open up my empty file, vim fraction.h, and I'll go and I'll grab the fraction.h file here and copy it and paste it into my window. Make sure you go all the way down and get everything in the window. So right click on that and copy, and then right click. Make sure you turn on insert before you paste. So remember, you're in VI, right? So go into insert mode, right click anywhere in the window, and it will insert it. It's often a mess, and in fact, let me just test something here. Yeah, it's still a mess. Okay. So pasting into VI can be a little bit dicey. The way to make this work is to hit colon like you're going to save and quit, but instead do set no set paste. Set paste, and then go into insert mode, and it'll say paste next to it, meaning that you're ready to paste something into the window. And then hit the right mouse button in the terminal. You don't have to hit Control V or anything like that. It's just the right mouse button. And that will paste it in there. Now hit escape, hit colon, set no paste, and now you're back to normal.
What if you have a map you can do it on the right hand button?
Use the command. Is it Command V?
It's control.
What's the regular paste command?
Oh, wow.
Command V. But that whole set paste, set no paste thing, you still have to do, Kendall. So yes, good question. Now I have successfully drawn the fraction.h file into my directory. The next thing to do is to start building fraction.cpp. So let's build fraction.cpp. And the first thing you have to do in your fraction.cpp file is include the fraction.h file. Oops, and use double quotes, not angle brackets, like that. Once you've done that, you are now ready to start defining the pieces of your class. There is a certain order that you should follow. You should build the default constructor first, because that's what allows you to actually declare fractions, is the default constructor. Let's do a little bit more VI here. I can edit more than one file at a time. So right now I'm in fraction.cpp. What I'd like to do is grab a couple of lines out of fraction.h and paste them into fraction.cpp. So I hit colon E. E stands for edit. And then fraction.h. That's the name of the file that I would like to open. And I hit enter. And what this does is it loads fraction.h, but fraction.cpp is still there. Right now, this VI editor is editing two files at once. Of course, I only get to see one of them at a time, but both of them are open. What's nice about this paradigm is I can copy two lines. Do you remember how to copy lines in VI? Y, or I can do Y to Y to get two lines. I want to grab these two lines right here. So I'm going to type Y to Y. Now the question is, how do I get back to the other file? There are several ways to do it. The easiest way is the following: :b $. And this will return you to the last file that you looked at. Now, I did y2y in the first file, and as long as I don't do anything to interfere with that, I can hit P in this file and get those two lines over.
Can you drop into stuff too?
Yeah, it's trickier though. So that's why I'm sort of modeling this instead of that. You can actually just highlight and paste using the mouse, and that works as well. So an alternative to this whole rigmarole is just to open up another file and then highlight in one and paste it into the other. That certainly works. And if you're having trouble pasting, do the set paste, set no paste thing. Sometimes for simple short stuff you don't have to do that, but lots of times for long stuff you do. So I'm going to write the default constructor first, and that is pretty standard. You should write the constructor first. You don't have to write all of the constructors, but at least one. Now, to tell the compiler that this function that I'm about to define is the constructor for fraction.h, I have to use the scope resolution operator. And this says, this function fraction that I'm about to build for you, it's a member of the fraction class. And we follow the comment. The comment says that this constructor should set the numerator to 0, the denominator to 1, and the sign to false. And in fact, the comment practically writes the constructor. Denominator and sign. I've made a design decision here. I've decided that if you don't specify anything and you declare a fraction, that fraction is going to be declared 0. There are lots of ways to define a fraction 0, right? 0 over anything other than 0 is 0. So I could put 0 over 1, 0 over 2, 0 over 500. The simplest thing to do is 0 over 1. But I'm not really bound to that. And of course, we decided by design that if we have a 0 fraction, the sign is false. So there I set the sign false. As I mentioned with the complex class, one really convenient thing about this syntax is I can build these things up one function at a time. So now I'm actually ready to write a program. A main.cpp. And again, main needs to be made aware of the definition or the declaration of the fraction class. So I have to include fraction. And at some point in this exercise, I'm probably going to print things out, so I'm going to just preemptively include IOStream. And using namespace standard. Int main. And at the moment, all I can do with my fractions is declare them. Let's see if that gives us an error. So the declaration of a fraction will invoke the default constructor. And we just wrote the default constructor. How do we compile something like this? Well, we've got all these files flying around. I talked a little bit about this before. From the command line, the easiest way to do this is just to list all the C++ files on one line. And then the compiler will go through all of those files and sort of glue them together and make an executable. No errors. A.out is created. It won't do anything, but at least it compiles and runs successfully. Let me go back into fraction.cpp and let's pretend that we didn't do this. This will actually still work. This is the default constructor, but there's actually a default constructor. There's one that just happens automatically. I lied. This used to work. Oh well. So you need a constructor. Used to be that you could do this without a default constructor and it would just run this cheap default constructor, and then your numerator would just be some random number, your denominator would be some random number, and your bool would be some random bool. But apparently that's not the case anymore. All right. Is that a sneeze? Bless you. We've got the default constructor. Let's see what we could do next. Oops. Well, I guess perhaps the next move would be to do this 3-argument constructor, which specifies the numerator, the denominator, and the sign. So I'll highlight that using V, get into visual mode, highlight it, then I hit Y to copy it, then I go back over to that other file and I paste it, and then I add the scope resolution. This is pretty standard. Now I've got to give myself some dummy variables, say a numerator, a denominator, and a sign. This uses unsigned ints to set numerator and denominator, requires a sign. Positive is false, negative is true, uses assert to force denominator not equal to 0. So if we're going to use assert, we have to include the cassert header. And I guess that'll be the first thing. Assert denominator not equal to 0. In the case where the denominator is 0, this will throw an error. And otherwise it'll just pass through. So it's a way of stopping the program in its tracks if the user tries to use your class incorrectly. Jordan?
What if you didn't have this and the user ran 2/0? What would it output?
It would work, but you would probably run into, at some point you would run into some errors, like probably when you got to division, you would run into some errors. And it certainly makes sense that you shouldn't have a denominator 0. So why not make that a condition of the class? Okay, help me out. What do I do next? So now the user of my class is building an object and is saying, I want the numerator to be this, the denominator to be this, and the sign to be this. What do I do with those 3 values that are coming in to my constructor? Where do I put them? Yeah, it's pretty, it's not very exciting. Am I done? Why? May not be in lowest terms. We don't know what the user specified. The user might have put in 2 for numerator and 4 for denominator, and those aren't in lowest terms. And the condition of the class is that these numerator and denominator values are always going to be in lowest terms. So I'm not done yet. I have to call reduce. That's a problem, though, because I haven't written reduce yet. So I can't actually finish this constructor until I finish writing reduce. Fortunately, we already have a reduce.
So are you going to declare that at the top of the function?
Yep.
Okay, no.
So now I'm going to go up here and put in reduce. Let me go find reduce. I think it's at the top of this. Yeah. So again, I'm going to highlight this whole section, and I'll copy it. I'll go in here. I'm going to turn on paste, go into insert mode, hit the right mouse button, escape, set no paste, and now I'm done.
I don't want to set.
Oh yeah, well, SE and set are the same in Vim. It's just a shorthand, and you can tell how much I use VI that I know that. But this is actually all ready to go, this reduce. It's just straight. As long as you use fraction.h without making any changes, which is what I'm expecting you to do, then this is a totally safe, just drop it in to your fraction.cpp. All right, let's go back now to main. And now we'll try to specify 1/2, 2/4. G++, fraction.cpp, main.cpp, and hope for the best. Okay, so it's compiling, and it probably runs. Still not getting much joy about whether I'm doing anything correctly. Where do you suggest I go next? I'd like to be able to debug this though. Make sure that it's actually doing something. Print it out in main. How do I print it out in main? I could try that, f.numerator. What's going to happen though? It's not going to let me do that. So I literally have to write the print function now before I can. Car.
From a debugging point of view, could you change your variables to not private just for now?
I think it's better to write the print function at this point, yes. So let's do that. So we'll go to fraction.h. Let's go down and grab the print function. Then we'll go to fraction.cpp. And we'll put it in there. The order doesn't really matter here. Put in the scope resolution operator. Put in that stuff. Okay. How shall we print one of our fractions? Well, if there's a description there, we should print the sign, the numerator, a slash, a denominator, and no end line. How do I decide whether to print the sign? And by the sign, I mean a dash. It does. So how would I make that happen? Print out a dash if it's true. So if sign cout a dash. If sign is false, what happens? Nothing. All right, so we've taken care of the sign. Numerator, denominator, what are some weird things about printing fractions with respect to the numerator and the denominator? Do I always print that forward slash? by no denominator.
That one.
Yeah, if the denominator's 1, I don't need to see that slash. What other weird case is there?
Oh, it would already do that in reduce, right?
Right, yep, good point. But yeah, if they're equal, that same thing will happen. If the numerator is 0, I just want to see the numerator. I just want to see 0. So I've got to deal with these essentially 3 cases. The case where the numerator is 0, the case where the denominator is 1, and the case where then it's just sort of generic numerator over denominator. If numerator, heck, we could just print out the numerator, right? Oops. I mean, that's coming out anyway, right? The numerator. And then how do we decide what to do with the rest of it?
So like it's not 0 or 1. You can put it on there.
Does that do it?
Well, pushing into 0.
If it's 0, the numerator is 0.
Oh, sorry.
What about like a?
What if it's 0 over 4?
So if the numerator is 0, don't see out anything.
So we could say or.
Yeah, that's it, yeah.
We could put an or up here. What were you going to say, Danielle?
Oh, well, I was just
You're good?
Like if denominator equal 1, or something, if denominator and then.
I think this captures everything. Yeah.
Not go right. Yeah. Gone.
So if the numerator is, what are you saying, Carter?
If the numerator is 0 right now, it will put it over 4.
If it's 0, I get this.
But your order statement says that it's going
Oh, it needs to be not that, right?
Yeah.
Sorry, yes. Good point. Okay. I think that captures it. I think it's or. If the denominator is equal to 1, I don't want to see it. And if the numerator is equal to 0, I don't want to see it. Or if the numerator is equal to 0. I think that works. Yeah. All right, so we've now written print. Let's go to main. And let's see if this is actually doing anything. F.print cout endline. Ah, yes. So I'm trying to use cout now in this file, so I need to include iostream to make that happen. That's good, right? That's what we expect. And you can play around with the various options. So now we've written a new function. This suggests that the 3-argument constructor is working and that reduce is working. There's a lot there. Fortunately, I wrote reduce for you, so you don't have to worry about debugging that guy. Let's go look and think about some other things we should test before we move on. Yeah, so let's try putting in 0 here. And ooh, that was exciting. I know what the problem is there. Yeah, my reduce function does have a bug in it. My reduce doesn't like having a 0 in there for one of its numbers that it's finding, so I'll fix that.
Can we test the negative one? Make sure the little sign works.
Yeah, and before I do that, I'm going to build a makefile. So I'm getting kind of tired of having to leave VI all the time and compile this thing, so I'm going to walk you through a makefile really quickly here. To make the main program, which is the default, main depends on the existence of main.cpp and fraction.o. And if those two guys exist, then the way to compile it is to go g++ main.cpp fraction.o. If fraction.o is missing, here's a rule to make it. And it depends on the existence of fraction.h and fraction.cpp. And if those guys exist, here's how you make fraction.o. And then I usually throw in one called clean, and that just removes a.out and star.o. And there's a nice simple makefile. Why do I want this? Because VI understands makefiles. And once I have this makefile written, I can do :make without leaving, and it'll compile things correctly. And then I can actually run it with this little command here: :!a.out. Oh, I still have my core dump in there. So let's go into main now, and I never have to leave VI again, and I feel so happy about that. Let's put a 2 back in there, and let's put true in here. So now this should be -1/2. Let me make, and let me run. -1/2. You could try some other sort of larger, more random kinds of numbers, I suppose. They're probably already relatively prime or something silly like that, but yeah.
Right side is negative.
Negative because it's still true, yeah. We could make these guys both even, then we're guaranteed to have 1. Okay. So you get the idea, and this thing, barring my 0 error, which I'll fix after class, there is that issue. That appears to be working. Okay, where do we go next? Pretty much go anywhere at this point. You now have the ability to build fractions. You have the ability to see what's in them using the print function. We could talk about this next one. So fraction int. So now the user is allowed to specify 2 integers, and those integers may be positive or negative. We don't have to do this, but let's talk through it here in the remaining 5 seconds. What's going to happen inside that constructor?
You could multiply them together, and if it's positive, make it the sign false, and if it's negative, make the sign true, and then just put the ints into
You could do that. So I could take the 2 ints, multiply them together, and if they're different signs, then I know that the resulting fraction is also going to be negative. The risk I run multiplying them together is an overflow. So it might be better to check, literally just check, is the numerator less than 0 and the denominator greater than 0? And then set the sign appropriately in all 4 cases. Okay? Okay. So you do that, you figure out what the sign is, possibly 4 cases. If somebody did it the other way, I probably wouldn't take off any credit, but just to try to stay consistent with the fact that we're using these unsigned ints, and trying not to limit ourselves unnecessarily, we might avoid multiplying those 2 guys together to avoid an overflow. So we figure out the sign. Then what do we have to do? I have to build the whole fraction. So I've got the sign taken care of. What's left to build a fraction? I have to assign something to the numerator and assign something to the denominator. What do I assign to the numerator? I have to figure out whether that first int is positive or negative, and then throw in the absolute value. So you're going to find, unfortunately, that the absolute value function doesn't work for. Actually, it might work. I was going to say it doesn't work. It might work for ints. So somehow you have to strip the sign off of that thing and shove it into the numerator and the denominator. Not quite done yet. So I've got the sign, I've got the numerator, I've got the denominator. Now what? I have to reduce. Don't forget to reduce. Have a nice break.